Hello everyone, welcome to Rafael Biotech Company. Today we would like to show you how to start up the system and prepare it to use. My name is Danny Asi and I'm from Hong Kong Metropolitan University. We are currently actively collaborating with Rafael Biotech Company to use their system in our application. Firstly, to use the system we need to turn on the computer by using the power on button located here. The computer is turning on. In the meantime, the second step is to turn on the quantum plasma biosensing system by pressing the turn on button located here. After that, we can open the system up. Now we will show you how to use quantum plasmonic software. To switch on the software, we need to click a quantum plasmonic icon on the desktop. Now we can see the user interface of the software. Firstly, what we do, we go to settings, we click optical command, we get camera parameter button, and we start the video stream. We do it to make sure that our optical parts and the chip is okay. Then we stop the video stream. Okay. The second step is to go to settings and combination command. Now we want to reset the system by clicking the execute button. Now we can see automated pipette mechanism in action moving up, so we can move out easily the sample tray from the system. So this is our sample tray. As we can see, we have 7 samples plus 1 place for the buffer solution. We start numbering system for the samples from the most right side in the front. So these are sample 1. We can change this for different concentration of our solution. This is sample number 2. We change this for another concentration, and we repeat the step for 7 samples as we are doing right now. So as you can guys see, it's very simple and easy to put the new samples in and out. And the biggest one is for buffer solution. So now we are putting back our sample tray to the system, as simple as that. So the next step is to go to settings and go to motor command. In this we go to aspiration position here, which moves our pipette mechanism up. As we can see, the pipette mechanism is going down back to our samples. And what is important is that the selection of the order which sample go first can be easily scheduled in the software. After inserting our sample tray to the system, now we will show you how to replace our 3D printing biochips. But before that, we need to understand how the liquid flows through our system. We have 4 main components here: sample trolley, valve, channel selector, 3D printing chip with a holder, and the pump. So the liquid goes through the samples to the channel selector. Then by using the inner tube, we insert the liquid to our chip located here. And then by outer tube, we suck out the tube to dispose the liquid. Now we will show you how to replace our 3D printing biochip. So now we will show you how to replace our 3D printing chip. We simply use one finger to take the holder out of the system. We can place this on the surface of the system like this. We unscrew one bolt to open the holder which holds our chip, like this one. We can put the screw here. We open our holder in this position. As you can see, our chip is located here. We simply push out the chip by our finger out like this. So now we are putting the new chip back to our holder. We have our inner tube here and outer tube here. We put the inner tube to the inner place on the chip, and we put our outer tube to the outer place on the chip. Simple as that. And we insert this chip back to the holder like this one, and we simply close our holder like that. We hold this and we screw one bolt inside the holder like this. We screw it like this one to make it tight. Now we see the back of our holder. We put the tubes on the trolleys to make sure that they are located correctly, and we put our holder back to the system when this screw is located towards left side, simply by one finger we can put it down to the system. So after inserting the new chip to the system, we go to the methods. We click ROA selection, which stands for area of interest. This is the new interface here. We need to click the get image. As you can see, this is our new inserted chip to the system, and the green rectangle here indicates our area of interest. As we can see, they are misaligned, so we need to make sure that they are aligned. How to do it is by simply clicking left button of the mouse in the area you think the new rectangle will cover perfectly the chip, like this one, and then we need to update the selected rectangle. The green one indicates the old one, the red one is the new selected area, and we click the update selected image. As we can see, this is our new rectangle. So after selecting our area of interest, we go to the methods, managing methods. This is our user interface here. We click add on the right side. By default we have 100 to 1200 frames. This number can be changed for whatever number we want, and then we click default Gantt chart. This provides us with our method procedure, what we want to do. As we can see here, we have 1200 frames, which means 1200 images, and we have, in this scenario, we have 5 samples. We have a baseline on the left side and the ending on the right side. So we have, for 200 images we have the sample 1, 200 images we have sample 2, and so on. For thermoplasmonic application, we have the option of turning on and turning off LED depending on the heating condition that are required. And after that, we are clicking the phase shift on the right side here, and we click OK. So after setting up the procedure that we need to follow, now we are going to the run step, which is located on the top bar. In this case, we are adding our run, which means we will run the method which we just saved. We click the button here, and here we are selecting the method which we saved in the methods, and we confirm the experiment, the procedure which is running out right now. So that's all for the demonstration of the quantum plasmonic software.